Chapter 1. The immigrant engineer John Augustus Roebling was born in Mühlhausen, Prussia, a small German town. Nothing about it suggested he'd end up reshaping American engineering. He studied at the Polytechnic Institute in Berlin, architecture, bridge construction, hydraulics, a broad education, built for a mind that liked to solve problems from the ground up. Before he ever set foot in America, Roebling picked up a German technical paper. It described early experiments in twisting wire into rope. Most people would have skimmed it and moved on. Roebling didn't. That single paper planted an idea that would define the rest of his life. In 1831, he left Prussia for good. He wasn't chasing a job. He was chasing a vision, a technological utopia built from scratch on American soil. He brought a group of fellow German immigrants with him. Together, they settled just outside Pittsburgh, Pennsylvania. They founded a town and called it Saxonburg. Here's what's easy to miss. Roebling didn't open a factory right away. He wasn't a businessman yet. He took a job as an engineer, working on a canal system for the state of Pennsylvania. That's the important part. Roebling was hands-on from day one. He wasn't a man who designed things from behind a desk and let other people build them. He was out in the field alongside the work. That instinct would define his legacy. It would also, one day, nearly kill his son. But that's still years away. Right now, Roebling is just an immigrant engineer with a folded piece of paper and an idea nobody else has thought to try yet. Chapter 1. The immigrant engineer John Augustus Roebling was born in Mühlhausen, Prussia, a small German town. Nothing about it suggested he'd end up reshaping American engineering. He studied at the Polytechnic Institute in Berlin, architecture, bridge construction, hydraulics, a broad education, built for a mind that liked to solve problems from the ground up. Before he ever set foot in America, Roebling picked up a German technical paper. It described early experiments in twisting wire into rope. Most people would have skimmed it and moved on. Roebling didn't. That single paper planted an idea that would define the rest of his life. In 1831, he left Prussia for good. He wasn't chasing a job. He was chasing a vision, a technological utopia built from scratch on American soil. He brought a group of fellow German immigrants with him. Together, they settled just outside Pittsburgh, Pennsylvania. They founded a town and called it Saxonburg. Here's what's easy to miss. Roebling didn't open a factory right away. He wasn't a businessman yet. He took a job as an engineer, working on a canal system for the state of Pennsylvania. That's the important part. Roebling was hands-on from day one. He wasn't a man who designed things from behind a desk and let other people build them. He was out in the field alongside the work. That instinct would define his legacy. It would also, one day, nearly kill his son. But that's still years away. Right now, Roebling is just an immigrant engineer with a folded piece of paper and an idea nobody else has thought to try yet. Chapter 2. Covered. From hemp to wire. Out in western Pennsylvania, on the inclined railways hauling goods up and down steep grades. There was a recurring problem. The ropes kept snapping. Hemp rope. Thick, twisted plant fiber. And it wasn't built for this kind of strain. When it failed violently. Accidents were common. Roebling had seen enough. He remembered that German paper he'd carried across the Atlantic. Wire twisted into rope. Stronger, more reliable. He decided to try it himself. In 1840, he pitched the idea to Pennsylvania's State Board of Public Works. He was turned down. No interest. He didn't stop there. In 1841, he sold his first batch of wire rope to a Pennsylvania canal construction project. It wasn't elegant. It was made on second-hand equipment, by hand, with none of the polish of a real manufacturing operation. But it worked. 1¼ inches thick, tougher than hemp, easier to handle. And it held. That was the proof of concept. 3 years later, in 1844, Roebling landed his first real engineering commission, a suspension aqueduct carrying water across the Allegheny River. Wire rope wasn't just a replacement part anymore. It was holding up a structure. Then came the moment that made his name. A suspension bridge across the Niagara Gorge. To prove the cables could handle real weight, Roebling did something bold. He sent a fully loaded freight train rolling across the span. It held. That single demonstration traveled fast. Word got out across the country. Roebling wasn't just an engineer with a clever idea anymore. He was the man who'd solved a problem the entire industry was struggling with. And solving it in Pennsylvania wasn't enough anymore. To meet the demand now coming his way, Roebling needed more space, better transportation links, and room to grow. That search would lead him east, to New Jersey. Chapter 3. Building Chambersburg. In 1848, Roebling bought 25 acres of land along the Delaware and Raritan Canal, in a district called Chambersburg. Today, that area is part of Trenton, New Jersey. Back then, it was just open ground with a lot of potential. The location wasn't random. Roebling picked it for very practical reasons. The canal gave him a way to move heavy materials in and finished cable out. The Camden and Amboy Railroad ran nearby, adding another transportation option. Trenton's port was growing, opening up wider distribution. And critically, the site sat close to the Cooper Iron Works, his source for raw wire. Everything a wire rope factory needed was within reach. Materials in, product out, that was the whole equation. But Roebling didn't just buy land and hire a construction crew. He designed the buildings himself. He designed the machinery that would go inside them. This wasn't a businessman writing checks from a distance. This was an engineer building a factory the same way he built a bridge, from the ground up, with his own hands in the process. He ran the company personally, every day, from 1848 until his death in 1869. 2 decades of direct control. No board of directors calling the shots, no committee slowing things down. While the factory took shape, Roebling's reputation as a bridge engineer kept climbing through the 1850s and into the 1860s. Each new project added weight to his name. Then came the Civil War. The Union needed cable, it needed rope. Military bridges had to go up fast, often under fire, and ships needed rigging that wouldn't fail at the wrong moment. Wartime demand poured in, and Roebling's factory grew to meet it. By the late 1860s, the company was thriving. Roebling himself was at the height of his career. None of them knew how little time was left before everything would change. Chapter 4. Tragedy, Triumph, and the Brooklyn Bridge. In 1867, Washington Roebling and his wife, Emily Warren Roebling, sailed to Europe. Not for a vacation. They went to study caissons, massive watertight chambers used to dig foundations underwater in dry conditions at the bottom of a riverbed. It was cutting-edge engineering, and Washington needed to understand it firsthand. Back home, John A. Roebling was finalizing plans for his most ambitious project yet. A suspension bridge connecting Manhattan and Brooklyn across the East River. He never got to build it. In late June of 1869, while surveying the site, a ferry crushed his foot against a piling. It seemed survivable. It wasn't. 3 weeks later, John Roebling died of tetanus. The man who'd spent 40 years perfecting suspension bridges was gone before construction on his greatest one had even started. Washington Roebling took over as chief engineer. He'd trained for this his whole life. What he hadn't trained for was what the caissons would do to his body. Work began in January 1870. Down in the caissons, temperatures hit around 80 degrees. Men worked half-naked in dim, flickering light. Washington didn't stay above ground and issue orders. He went down with his crews again and again, spending more time in that pressurized air than almost anyone else on the project. By 1872, it caught up with him. A severe attack of what workers were calling caisson disease left him barely able to move. He wasn't alone. More than 100 men developed the same condition during construction. Some recovered, some didn't. Nobody yet understood that the real danger wasn't the pressure itself. It was rising back to the surface too fast. Washington survived, but he'd never fully recover. From then on, he directed the project from a bedroom window in Brooklyn, watching the bridge rise through a telescope. That left a gap, and Emily filled it. She became the daily presence at the construction site. She met with engineers. She sat in on board meetings. She taught herself the engineering she needed to translate her husband's instructions into action, and to make decisions when there wasn't time to ask him first. On May 24, 1883, the Brooklyn Bridge officially opened, the longest suspension bridge in the world. The first ever built with steel wire cable. A father who never lived to see it. A son who nearly died finishing it. And a wife who kept the entire project moving when neither of them could. Chapter 5. World's largest wire rope plant. After John A. Roebling's death, the company didn't fold. It reorganized into John A. Roebling's Sons Company, run by his three sons, Washington, Ferdinand, and Charles. Three brothers, one factory, and a name that already carried serious weight. They didn't just maintain what their father built. They scaled it. By World War I, the Trenton factory had become the largest wire rope plant on Earth. Not the largest in New Jersey. Not the largest on the East Coast. The largest anywhere. At its peak, around the end of the First World War, the company employed roughly 10,000 workers. Production spread across 5 factories, several in the Trenton area, and more in a company town the Roeblings built specifically to house this operation. A town they simply named Roebling, New Jersey. In 1904, they added the Kincora Works to that town. A massive steel and wire-making facility, purpose-built to keep pace with growing demand. And the list of projects kept expanding. Roebling Cable helped build the Panama Canal. It went into the George Washington Bridge, linking New York and New Jersey. During the Great Depression, it went into the Golden Gate Bridge, spanning San Francisco Bay, one of the most photographed structures in American history, held together in part by cable made in Trenton. During World War I, the factory shifted some production toward the war effort, manufacturing submarine netting for the North Sea mine barrage. A defensive barrier meant to block enemy submarines from slipping through. World War II brought another surge. Military contracts pushed employment at the Roebling town facilities past 5,000 workers on their own. It was the last great boom the company would ever see. By this point, the numbers were almost hard to picture. 4 factories, 258 buildings, 4.5 million square feet of floor space combined. This wasn't a factory anymore in any small sense of the word. It was an industrial ecosystem, employing thousands of families, shipping product to every corner of the country, and quietly holding up some of the most important infrastructure America would ever build. From a folded German paper in an immigrant's pocket to the largest wire rope operation in the world, that's the distance this company had traveled in less than a century. But peaks don't last forever. And the next chapter of this story starts somewhere very different. Inside the walls of the town, the company built for its own workers. Chapter 6. Life in the company town. A workforce this large needed somewhere to live. So the Roeblings didn't wait for the market to figure it out. They built the town themselves. Charles Roebling took charge of the design personally. Not a hired architect working from a brief. Charles himself, laying out the streets. He chose a modified grid pattern, the kind of layout that makes a town easy to navigate and easy to expand. 2 main avenues cut through the plan, intersecting the grid and giving the whole town a sense of order. Main Street ran in a straight line to the gatehouse of the Kinkora Works. Walk out your front door, follow that street, and you'd be standing at the factory gate in a matter of minutes. There was no ambiguity about what this town existed for. But it wasn't just streets and row houses. This was a genuinely self-contained community, and the company owned every piece of it. A school for the children, healthcare facilities for the workers and their families, a library, hotels for visitors and newer arrivals, an assembly hall for gatherings, a park, athletic fields, a recreation center. If you lived in Roebling, New Jersey, you could go your whole life without needing anything the company hadn't already built for you. That's worth sitting with for a second. Your job, your home, your doctor, your kids' school, your Saturday afternoon at the park. All of it ran through the same company. For workers, that could mean stability. It could also mean there was no real separation between where you worked and where you lived your entire life. Even the housing carried a message. The homes were built of brick, topped with slate roofs. Solid, built to last, not thrown up cheaply. But the size of your house, and its distance from the mill, wasn't random. It mapped directly onto where you sat in the company hierarchy. Skilled workers, the ones with specialized trades and more seniority, got the larger homes. And those homes sat farther from the noise and grit of the factory floor. Everyone else lived closer in, where the sound of machinery never really stopped. Walk down any street in that town, and you could probably guess a man's job just by looking at his house. Workers didn't own these homes outright, at least not at first. They rented them from the company, paying a modest monthly rate, nominal by most accounts. Low enough that housing was never the thing standing between a family and stability. Over time, though, that changed. Many of these workers eventually bought the very houses they'd spent years renting, turning company housing into something that actually belonged to them, deed and all. The town had its own culture too, and it wasn't just infrastructure and paperwork. In the 1930s and into the 1940s, the mill's own football team, known as the Blue Centers, made up entirely of men who worked the plant floor during the week, became something the whole town rallied around. On game day, this wasn't about steel production or shift schedules. It was neighbors cheering for neighbors. For a company town built around repetitive, demanding labor, that team gave people something to look forward to that had nothing to do with output numbers or quotas. Back in Trenton itself, the Roebling name had worked its way into the identity of the entire city. There's a bridge there, the Lower Trenton Bridge, carrying a slogan that's become one of the most recognized industrial mottos in American history. Trenton makes, the world takes. That phrase wasn't just a catchy line dreamed up by an advertising office. It was a statement of fact. And Roebling, more than almost any other single company, was the reason it held true. When people thought of what Trenton made and sent out into the world, wire rope and cable were near the top of that list. What you're looking at in this chapter is a closed loop. A company that built its own factory, then built its own town around that factory, then built its own culture inside that town, its own schools, its own sports teams, its own sense of identity, all self-contained, all traceable back to the same source. But that wire wasn't staying local. While families were growing up inside this company-built world, Roebling cable was already leaving Trenton far behind, heading into elevators rising through city skylines, into mines cut deep underground, into airplanes and power lines stretching across the entire country. That's where this story goes next. Chapter 7. One wire, 1,000 uses. Bridges made Roebling famous. But bridges were never the whole business. By the time the company hit its stride, wire rope from Trenton was showing up in places that had nothing to do with suspension cables at all. Roebling's sons had quietly become one of the main suppliers of wire and cable to almost every corner of American industry. Start with elevators. Back in the 1860s, the Otis brothers, the same family whose name is now practically synonymous with elevators, began using Roebling cable in their lifting systems. That partnership mattered more than it might sound like. Strong, reliable cable is exactly what makes it possible to lift heavy loads dozens of stories into the air without the line snapping. Every time a skyscraper went up higher than the one before it, elevator cable had to keep pace. Roebling wire helped make that possible. Cities needed cable too, just for getting around. Cable cars and tramway systems, the kind that once defined urban transit in places like San Francisco, relied on continuous loops of wire rope running beneath the streets. That wire took the same basic technology Roebling had proven on the Niagara Gorge Bridge and put it to work hauling passengers up steep city hills instead of freight across a canyon. Then there was the electrical grid, still taking shape across the country. Power transmission lines needed wire that could handle tension and weather without failing. So did the expanding telegraph network, and later, telephone lines. As America wired itself together, literally, Roebling wire was often part of that infrastructure, strung pole to pole across whole states. Heavy industry needed it just as badly. Mining operations used wire rope for hoisting equipment and moving material out of the ground. Logging operations used it to drag and lift timber that weighed tons. Oil drilling operations used it too. As that industry expanded and needed cable that could handle the stress of pulling equipment up and down deep wells, wartime brought yet another use. Aircraft manufacturers needed wire for structural components inside the airframe itself. And as covered earlier, the company produced netting for underwater submarine barriers. A very different application from anything Roebling had built for in the 1800s, but built on the exact same underlying wire rope technology. And then there were the uses nobody would guess. Roebling wire went into musical instruments, providing the kind of tension-bearing wire that certain instruments depend on. It went into cables for ski lifts, carrying people up mountainsides instead of across rivers. It reinforced pre-stressed concrete, the technique that lets concrete structures handle far more load than the plain concrete ever could. It was woven into wire cloth and screens, used in construction and manufacturing settings all over the country. Stop and take stock of that list for a second. Bridges, elevators, cable cars, power lines, telegraphs, telephones, mining, logging, oil drilling, aircraft, submarine defense, musical instruments, ski lifts, concrete reinforcement, wire screens, one factory, one core product, wire rope, feeding almost every major industry America had. That kind of diversification was a genuine strength. No single customer, no single sector could sink the company by pulling back. If bridge construction slowed down for a few years, mining and elevators kept the orders coming. If wartime demand spiked, aircraft and military contracts picked up the slack. But there was a quieter risk buried inside that same success. Every one of these industries, mining, aircraft, elevators, power infrastructure, was itself part of a much larger system, America's mid-century model of heavy industrial manufacturing. Roebling wasn't just tied to one customer. It was tied to an entire era of how the country built things, at massive scale, in massive factories, with massive workforces. That model had carried Roebling from a folded German paper to the largest wire rope plant in the world. But models like that don't last forever. And after World War II, the very foundation this company had built its empire on was about to start shifting beneath it. Chapter 8. The first cracks after the war. Through the 1940s, the mill in Roebling, New Jersey was running at full capacity. World War II contracts kept the orders coming in steadily, and the town built around that factory was living through its best years yet. Football games on Saturday. Full employment. A company that seemed like it would run forever. Then the war ended, and the ground underneath the whole operation started to shift. This wasn't unique to Roebling. Across the country, heavy manufacturing began slowing down after the war. Military demand, which had been propping up factories like this one for years, dropped off fast. At the same time, competitors were emerging, some overseas, some domestic, offering wire rope and steel products at prices Roebling hadn't had to worry about before. The company that once had almost no serious rival now had to think about market share for the first time in decades. None of that showed up overnight as a factory closing or headline in the newspaper. It showed up somewhere quieter, and somewhere that says more about what was actually happening than any earnings report could. The company started selling off its worker housing. Remember the town Charles Roebling designed? The brick homes, sorted by seniority, rented out at modest rates because the company wanted stable, rooted workers close to the mill. That entire system depended on the company being willing to hold on to real estate as a long-term investment in its workforce. Selling that housing to the very people renting it wasn't just a real estate transaction. It was the company quietly stepping back from the thing that had made this town different from an ordinary factory town in the first place. The closed loop from Chapter 6, job, home, school, park, all under one roof, started coming apart, piece by piece, house by house. Then came the transaction that changed everything. In 1952, some records put it a year later, in 1953, the Roebling family sold the entire company. The buyer was Colorado Fuel and Iron Company, a steel conglomerate based more than 1,000 miles away, in Pueblo, Colorado. Sit with that for a second. More than 100 years after John A. Roebling bought 25 acres along a canal in Chambersburg, his family's name was still on the letterhead. But the family wasn't running it anymore. The Roeblings were out. This wasn't a hostile takeover or a bankruptcy. It was a sale, and by most accounts, a reasonable business decision given the direction heavy manufacturing was heading. But the result was the same either way. A company that had been personally designed, personally engineered, and personally managed by 3 generations of one family was now a division inside somebody else's steel empire. One plant among many on a much larger balance sheet. That mattered more than it might seem. When you're the flagship, the crown jewel, the thing your name is built on, you get priority, investment, attention, modernization budgets. When you're one plant inside a much bigger company headquartered somewhere else entirely, you become a line item. And line items get reviewed for cost, not legacy. Colorado Fuel and Iron took over operations, and to their credit, they didn't shut things down immediately. The Kincora works kept running, but modernizing an aging industrial complex, replacing outdated equipment, upgrading processes, takes real capital and real commitment. CF&I struggled on both fronts. Environmental requirements were tightening across the industry during this period too, adding another layer of cost and complexity to a plant that was already showing its age. The factory that once symbolized American industrial dominance was now just trying to keep pace. Not lead, keep pace. None of this looked like collapse yet. The mill was still open, people were still showing up for shifts. But underneath the surface, the foundation had shifted in a way that couldn't be undone. Ownership had changed hands. The company-town model was dissolving, and the new owners weren't investing in this plant the way the Roeblings once had. The cracks were there. They just hadn't reached the surface yet. That would come next. And when it did, it would come fast. Chapter 9. The long shutdown. Colorado Fuel and Iron ran the Kincora Works for 22 years, from 1952 to 1974. On paper, that sounds like stability. In practice, it was a slow-motion holding pattern. The plant was aging. Foreign competitors were producing wire rope and structural steel at lower costs, and demand for the kind of heavy cable Roebling had built its name on was shrinking year over year. CF&I didn't have the resources, or maybe just didn't have the will, to make the kind of investment that could have turned that trend around. They kept the lights on. They didn't modernize enough to compete. Eventually, the math stopped working. In 1974, the mills shut down. Both of them, the original operations connected to Trenton, and the Kincora Works in the town of Roebling itself. Not a slowdown. Not a temporary layoff. A full closure. Roughly 1,400 workers lost their jobs, essentially all at once. In a region where this factory had been the economic backbone for over a century, that kind of loss didn't stay contained to the people who got the pink slips. It rippled outward, through Florence Township and the surrounding area, hitting local businesses, local families, an entire regional economy that had been built around the assumption that this plant would always be there. For a moment, it looked like there might be a second chance. In 1979, a new company formed with a familiar name, John A. Roebling Steel Corporation, or JARSCO. It wasn't the original family stepping back in. It was a new venture, backed with financial assistance from the Economic Development Administration, a branch of the U.S. Department of Commerce. The goal was straightforward. Restart production, bring back jobs, give this site one more chance to work. It didn't take. JARSCO managed to operate for 2 years. By 1981, it had shut down as well. Whatever combination of market conditions, capital shortfalls, and operational challenges had killed the plant the first time hadn't gone away, just because the name on the door changed. The revival attempt was over almost as quickly as it started. After that, the site entered a strange kind of limbo. The Economic Development Administration held onto the property and the equipment as a creditor, technically in possession, but with no active operation running. That arrangement lasted for 2 decades. It wasn't until 2001 that the EDA finally turned the property over to Florence Township, the local government now responsible for a site nobody had figured out what to do with. By the 1980s, a bigger problem than idle buildings had surfaced. The Environmental Protection Agency inspected the site and found conditions serious enough to classify it as a threat to public health. Toxic materials were sitting inside the abandoned buildings. Groundwater beneath the property was contaminated. So were nearby waterways. Decades of industrial production, steel, wire, chemical treatments, everything that goes into running a plant this size for over a century, had left a footprint that didn't just disappear when the machine stopped. In 1983, the site was formally added to the federal government's National Priorities list. In plain terms, it became a Superfund site. One of the most contaminated locations in the country, officially recognized as needing intervention the local government and private owners couldn't handle on their own. Cleanup began in 1985. It wasn't quick and it wasn't cheap. The remediation process stretched across roughly 20 years and cost in the neighborhood of $70 million. Public money, spent to undo the environmental damage left behind by a company that no longer existed in any form capable of paying for it themselves. Picture what was actually sitting there while all of this played out. At the height of operations, the Kincora Works alone had grown to around 70 buildings. 70 structures that had once hummed with machinery, employed thousands, and shipped cable to bridges and mines and power lines across the entire country. Now they sat empty, contaminated, fenced off, waiting for a cleanup that would take longer than most of those buildings had been standing. The company that once held the record for the largest wire rope plant on Earth had ended up holding a very different kind of record, a federal designation nobody wants attached to their name. Chapter 10. What the cables left. Cleanup on a Superfund site doesn't end with a ribbon cutting. It ends quietly over decades, one contaminated section at a time. But eventually, this one did end. And what came after wasn't another factory. It was something closer to a memorial, the 1907 Main Gate Building. The same gatehouse Main Street once led straight to, back when this was a working company town, got a $6.3 million renovation. It didn't reopen as an industrial facility. It reopened as the Roebling Museum. Walk through those doors today, and instead of shift supervisors and payroll offices, you'll find the actual story laid out. The family, the company town, the inventions that came out of this site. The gatehouse that once controlled who got into the factory now controls who gets to learn its history. That wasn't the only piece of this place formally recognized as worth preserving. The Roebling Historic District, along with Block 3 of the original Trenton factory complex, buildings dating from 1908 to 1929, was added to the National Register of Historic Places. Block 3 specifically earned that recognition on August 22, 2012. Buildings that once produced wire rope for a living are now legally protected as pieces of American history. But here's the thing worth sitting with. The most important legacy of this company was never going to be a museum building or a historic plaque. It's not really in Trenton or Roebling at all. It's in the bridges. Every single day, millions of people cross the Brooklyn Bridge, the Golden Gate Bridge, the George Washington Bridge, three of the most recognizable structures in the entire country. None of those bridges are museum pieces. They're active, working infrastructure, carrying cars and pedestrians and subway trains right now, today, using cable technology that traces directly back to a factory that no longer exists. The company died. The product it made didn't. It's still up there, holding weight, doing exactly the job it was built to do, more than a century later. That gap between a company's lifespan and the lifespan of what it actually built is worth thinking about for a second, because it's the whole story compressed into one idea. Go back to Washington and Emily Roebling for a moment, because their part of this story carries a lesson that has nothing to do with factories or balance sheets. Washington nearly died proving that human ambition can outrun human understanding. Nobody in the 1870s fully understood decompression sickness. They knew going into the caissons was dangerous. They didn't know exactly why or exactly how to prevent it, until men had already been paralyzed and killed, finding out the hard way. That's the cost of building at the edge of what science actually understands. Sometimes you find the edge because someone gets hurt finding it. And then there's Emily, a woman who had no formal engineering training at a time when women weren't permitted to become engineers at all. Ended up running the day-to-day operations of one of the most complicated construction projects in American history. She wasn't given credit for it publicly while it was happening. She deliberately kept her role quiet, worried her husband would lose the position if people knew how much of the actual work was hers. But without her, there's a real argument that the Brooklyn Bridge doesn't get finished. That's not a footnote. That's the difference between a bridge that exists and one that doesn't. Now zoom back out to the company itself, because there's a second lesson here, and it's a colder one. This was a business that dominated a global industry. Wire rope, cable, the exact material holding up some of the most important structures in the country. For over 100 years. 10,000 employees at its peak. the largest plant of its kind on the planet. And it still managed to disappear in a matter of decades. Not because the product failed. Not because the bridges came down. The bridges are still standing right now. The company failed because the world around it changed. Foreign competition, shifting demand, tightening environmental standards. And it stopped being owned and run by people who were personally invested in solving those problems. Once the Roebling sold, this stopped being a family's life work and became a line item on someone else's balance sheet. And line items get abandoned when the math stops working. That's really the whole story. If you compress it down to one sentence, a structure can outlive the industry that built it. A bridge doesn't need its factory to survive. It just needs to have been built right the first time. So the next time you're crossing a suspension bridge anywhere in America, and you look up at those cables running overhead, holding thousands of tons of steel and traffic in the air, there's a decent chance you're looking at an idea that started with one immigrant, one folded German paper, and a factory that doesn't exist anymore. The machine stopped. The town changed hands. The buildings became a Superfund site and then a museum. But the cables are still up there, still holding. That's what's left behind.